Let's look a little bit at the processes and the numbers on greenhouse gas emissions. Obviously, it should depend on the type of soil, the vegetation, climate, and so on. So, just to remind ourselves, we have solar energy driving photosynthesis and creating carbohydrates for soil organisms, which are going to respire it and produce a CO2. Plants exude carbohydrates through their roots to feed all these organisms, which there is a symbiotic relation, of course, because the carbohydrates are converted back into the nutrients that the roots take up. CO2 from the atmosphere enters the soils through decomposing plant matter, root exudates, and soil organisms that feed on them. So there is CO2 built up in the soils, the pore waters, and so on and so forth, right? So that's part of the terrestrial carbon cycle. So the key drivers of greenhouse gas emissions from soils obviously depend on local and regional climate, especially in terms of the amount of rain and number of sunny days, amount of vegetation, kinds of vegetation, rainforests versus boreal or temperate forests versus deserts or drylands, and so on and so forth. Hydrology, I hope you have a general sense. It is the movement of water through the land, ocean, atmosphere system. Evaporation, for example, from the ocean, most of it falls back on the ocean. Some of it is carried onto land as rain or clouds or snow, and then it flows into the rivers, soaks into the ground, becomes groundwater or surface water, flows back to the ocean or accumulates in lakes, and so on and so forth. Okay, so let's look at a few things here. Land use, transformation, and ecosystem resilience are affected by that. So land use is anything that is changing natural landscape from forests to agriculture, from agricultural to urbanization, or converting land into lawns for beauty of the house, and so on and so forth. Land cover, forest lands, grasslands, barren lands, croplands, wetlands, and other types. They all have different impacts on the amount of greenhouse gas emissions, and the ability to store carbon is changed as well. Vegetation, age and type distribution, leaf area index. So how much leaf coverage is there? Okay, nutrients, carbon to nitrogen ratios, land use management, atmospheric deposition. So we will talk about fertilizers in a minute, but there is a lot of airborne nitrate in the air, either formed by lightning of nitrogen, which is the most abundant gas in the atmosphere, or being picked up from land, excess fertilizer application, and so on. And there is wet and dry deposition of these on land, on water bodies, and so on. Carbon to nitrogen ratios matter because that determines the species in the coastal waters of phytoplankton, or consumption in the soil, and ability of the plants to take it up, and so on and so forth, which again affect greenhouse gas emissions. High carbon content is generally good, but one has to also see how that affects greenhouse gas emissions. Humidity, obviously, soil water content, water-filled pore spaces, precipitation, and drought. We will see that intensity and frequency of droughts may be increasing, temperatures definitely increasing. So radiation, exposure of soil cover and organic carbon, soil color, so mineralogy, what kind of minerals. We saw that some red color was there. In India you will get very black soil and red soil depending on what is the major content of the soil in terms of minerals. And wildfires, of course, affect the carbon emissions. So this is just a quick look at the total CO2 equivalence here. It is shown in milligrams CO2 equivalent per meter squared per hour. So it's a very local measurements, but it is covering various gases here from CO2, methane, N2O, and total CO2 equivalent, as well as various types of vegetation: forest land, grassland, barren land, cropland, and wetland. And because it's a very high frequency measurement, you can see that many of the numbers are here close to zero, but if you average them over a day or a week or a year, those numbers are not small, right? For example, methane and nitrous oxide are down here, but you can see the range can be very different. Okay, so forest land has a high CO2, 400 milligram CO2 equivalent per meter square per hectare per unit area per hour. Per hour, not hectare. This is total CO2 equivalent, including, so you can see almost the same because these are low. Grasslands, barren land, all are low, obviously. And there are some peaks here that are beyond the scale. So over the grassland, total CO2 equivalent can go here up to 2560 milligram CO2 equivalent per meter square per hour. Cropland, high amounts here, so agricultural conversion obviously can increase greenhouse gas emissions. So even though the measured fluxes here are lower than forest land, the emission here peaks much higher. Wetlands, total CO2 is quite high. Okay, so this is something one has to think about. It has higher methane and higher CO2 flux and total CO2 equivalent as well. But wetlands also sequester a lot of carbon, as we will see later on, because of their typical waterlogged state. So organic matter versus organic carbon versus inorganic carbon. SOC inputs and outputs that are sensitive, that are typically sensitive to climate and weather, as we saw just now. Temperature, precipitation, storms and droughts make a difference. Geology, the rock types and the weathering rates, amount of rain, for example, or amount of vegetation, root depths, and so on. Soil age, landscape and landform stability. So the slopes and the vegetation on the slopes, amount of rain. In India, for example, Western Ghats and the Himalayan foothills are very steep slopes, can be, and have thick vegetation which should actually stabilize the slopes. But if you deforest them or you put monocultures on them like rubber, then the same amount of rain can induce landslides and loss of soil organic carbon as opposed to natural vegetation. Biology, of course, vegetation, microorganisms and animals, grazers and so on, especially the big ones like elephants, can have an impact on the soil organic content in the soils. Soil organic carbon in the soils. Well, you know what I mean.